Hey there, it's Nate. This was a bad day to wear this shirt. Hey there, it's Nate. And doesn't this planet ever get boring to you? I mean, I was raised in Idaho, but roll the logo. People have been talking about leaving this planet for a while now. Interest in Mars has recently sparked planning by both public and private institutions such as NASA and SpaceX. In June of 2017, the US National Space Council was finally reestablished, with current goals to go to the moon before eventually going to Mars sometime in the 2030s. I'm not going to talk about a mission in Mars for this topic, more of Vamonos to Venus. Now, before I get into Venus in particular, I'll have to talk about getting to another planet in general. See, humans are picky things. We need a certain oxygen level, a certain temperature, certain gravity conditions, memes. Building the deep space habitation just to get to the planet is no small feat. In anticipation of the Mars mission, the companies Bigelow Aerospace, Boeing, Lockheed Martin, NanoRacks, Orbital ATK, and Sierra Nevada Corp were selected by NASA to design deep space habitats back in August 2016. You can find out more about these in the link in the description. Once we get to the planet though, we have a similar issue. To live on the planet continuously without exhausting resources, we're going to have to simulate an Earth-like environment to grow food and support life. The mainstream idea of how to do this is called terraforming, which means to transform a planet into an Earth. The idea of terraforming isn't new. It's been around for at least a century, and some records suggest even older than that. The idea is deceptively simple. Take a non-Earth-like planet and manipulate key features like the atmosphere, environment, etc. to make the planet habitable. Now, the atmosphere is actually the reason I'd like to focus on Venus rather than Mars. That and because, Mars has been covered like a million times. In the long run, Venus may be more realistic to terraform, even though it will initially be massively more difficult. The surface gravity of Venus is about 91% of Earth's, whereas Mars is only around 38%. Earth and Mars have very different gravities, which means that bone deformities and other medical problems may appear quicker than modern medicine can even handle. In fact, in recent thought experiment proposed by NASA's Planetary Science Vision 2050 workshop was titled Mars Terraforming, the Wrong Way. As you can imagine, the paper rejects the idea of terraforming Mars altogether and presents an alternative. Ensure humans can live and be reproductive in space habitats. That way our human biology can be better satisfied. In 1954, Poul Anderson wrote a fictional piece about terraforming Venus called The Big Rain, in which Venus is altered with planetary engineering. So what is the real-life Big Rain plan to terraform the harsh, thick atmosphere of Venus? Well, let's take a trip to see for ourselves. We're going on a trip in our favorite rocket ship, going through the sky, little Einsteins. Wait, is that recording? To terraform Venus would require three major changes. The first two being to decrease the temperature and to reduce the carbon dioxide in its atmosphere. These two things are actually related due to the greenhouse effect. By reducing Venus's carbon, we'd in turn decrease the temperature. Kinda wish we could do that here on Earth. The third change is adding life support, producing oxygen, water, and the ever so underrated particle, nitrogen, for growing plants. Don't forget that unlike Mars, Venus has no evidence of water on its surface. But wait, don't despair. Remember that CO2 from earlier? Author and aerospace engineer Robert Zubrin proposed a chemical equation to use CO2 in the case for Mars. If we bring our own hydrogen to the CO2 atmosphere, we get ourselves a nice source of water with Zubrin's equation. And since hydrogen is much lighter in mass, we can send more hydrogen than we ever could bring in actual water. While the question presented in this video may not be fully answered yet, people like you are helping fuel more research just by watching this video. Remember to subscribe and to like for more content. If you enjoyed this video or learned something, remember to share this video with your friends and comment down below on your suggestions or ideas on this topic. This video's featured user is Whatify. Remember to join my Discord and to recommend video ideas, ask me questions, and enter giveaways and challenges. Remember to check out my Patreon to help me bring more content out to you and to get a chance to win free stuff. Thank you guys so much for watching, and I'll see you in the next video.